Are we ready to begin? Yes. All right, so today our enabling learning objective. Number 2, building foundations. Action. Identify types of building foundations. Conditions. Given a classroom environment, a TM 3-34.47, a TM 3-34.44, a vertical structures workbook, and a highly motivated Ebola class. Our standards identify various types of building foundations in accordance with applicable references. Foundations. Right? We talk about foundations in many things, but we also talk about them in our lives, about what a strong foundation is and how we can kind of drive forward with our lives if we have a strong foundation. And as a former surveyor, I realized that if you start well, you usually end well. So the foundation is the important. If you don't get the foundation right, you will have troubles with everything else in your construction. If your foundation is not level, if it is not square, everything else will be thrown off. And you'll see that later on when you go into your QA/QC at Brown Hall. Going into a little bit more about foundations, you have to understand what kind of loads are put on them. And we mostly speak about dead loads, live loads, and frost heave in our engineering course here. There are other types of loads and other types of pressures that are put on them while that we talk about in engineering college and in your degree programs. Maybe some of you guys might know them, like static loads and so on and so forth. We're not really going to address those here. We're going to talk about the generics. Dead load. Anybody tell me what they think a dead load is? Yes?
All of the weight of all the materials of the actual building.
Okay, very good. What else? What might that include?
Anything that's not going to be moved easily, so fixtures, bathtub, sinks.
Okay, very good. Anything else? What's that? Toilets? He's mentioned fixtures, bathtubs. What else? What are some of those other elements that might be in there?
Desks, chairs.
Desks and chairs. Can desks and chairs be moved?
Yes.
Yes? So they might not always be considered a dead load. However, they do kind of sit there most of the time. But the utility portions, what else does somebody say over here? Some? No? The actual weight of the building? Yes, everything that has been mentioned here. Yes? The roofing material as well. What about live loads? Appliances that could actually function like a dishwasher or dryer. People. What else? Snow loads. Yes, that could be as well. You mentioned earlier furniture. You know, you're sitting in a chair. That's definitely a live load. Yeah, wind. Definitely a live load. What else? Squatters. Okay, great. Yes?
So are we including like snow load and stuff like that as part of the live load?
Yes, we are. In this case, we are. We understand that those are usually considered in a separate category, but as far as we're concerned here, they are that. Okay? Also, another aspect we're going to talk about is frost heave. And what frost heave is, if you do not build below the frost line. Who does not know what a frost line is? It's okay. That's good. All right. What a frost line is at a certain level below the ground, below the surface of the ground, it stays the same temperature all year round. So it doesn't matter if it gets super cold or super hot, it's going to stay the same temperature. So in the dead of winter, when the ground is frozen, you dig below to that certain point, the frost line, it will not be frozen anymore. So your footings, as I've kind of created a diagram up here, who here is from the north or lived in the north? A lot of you guys, okay. Who has never lived in the north? A few of you. Okay, let's also break this down. Who's never been in deep snow before? Okay, a few of you. Who of you are very familiar with deep snow? Yeah, quite a few in this class. Okay, what's it like walking through snow? Awesome. Awesome? All right. You kind of wind up falling through and you wind up getting all the way up to your hip and kind of halfway sinking, and trying to trudge through that can be rather difficult, right? And why do you sink through the snow? Because you're heavier than the snow, right? And your feet are really thin. Same thing happens when you walk across thin ice. You're going to go through it, correct? You ever notice that? You ever hear, or maybe you didn't notice, but you ever hear that animals like dogs can walk across thinner ice than you can? That's because they distribute their weight a little bit more than we can, because they have 4 feet. Now, it's pretty funny watching them walk on there, but they can distribute their weight a little bit better than we can. So if you're going to walk on snow and you just try walking normally, you're going to have troubles. So what is a way to, overcome that problem? Snowshoes. Snowshoes, very good. And what does snowshoes do? Distributes your weight so that you're able to walk on this surface here. Now, what your foundation does is exactly the same thing as snowshoes. If you just have a wall or a column pushing straight down, they're going to eventually punch through the soil. Maybe very slowly, but that's exactly what it's going to do. So what you have is a wider footer that distributes the weight, and the ground can take it better, all right, and support that building. And we're going to talk about various types. Now let's get into some of the terminology, right? When you look at a building, you have your column right here. Of course, it has a footer. Then you have your foundation walls. Again, they also have a footer. It just so happens to be a longer one, right? Then you also have your slab on grade, which we spoke about earlier, right? Yesterday, 2 days ago. You all remember this? Yes. So that's your foundation, and then you're going to have your superstructure built up above that. Now, when we talk about those footings, there are a few rules of thumb that we focus on. One of those is about the width of a footing. I mentioned to you a couple days ago about the width, about determining the width for a wall or a column is different than determining the width of a footer. And we understand that a width for a wall is about from here to here, right? Yes? Yeah, we talk about how thick the wall is or how wide the wall is. It's right here, right? Okay? Now we talk about how thick a wall is horizontally. When we talk about how thick a footer is, or a slab on grade or anything like that, we're talking about from top to bottom. This will confuse you later on if you start talking about the width of a footer versus the thickness of a footer. Understand? So that's a little just engineerism that you're going to find that's out there in the field, and you will run into it and you will make incorrect calculations based upon that if you are not familiar with the terminology. Okay, so from there on, if you have the thickness of that wall is, let's say, 6 inches, the footer will be double that, all right? So the width of the footer will be double the thickness of a wall. Okay, so if this is 6 inches, the footer will be 12 inches wide, but the same thickness as the wall thickness. So for example, this is an 8-inch thick wall. How thick will this footer be? No, how thick will it be? 8. And the width will be what? 16. Right? So if the wall is 8 inches thick, this will be 8 inches thick right here, and then double that, 16. Does everybody understand this? All right, so remember your terminology when you talk about width versus thickness. Oh, now we are going to our enabling learning objective number 3, wood frame construction. Now you've noticed that we have stepped from concrete the other day, right? And prior to that, you guys were doing horizontal in the other course, correct? So now we're progressing from horizontal, concrete. We've talked about our foundations. Now we're going to talk about wood frame construction. So the action, identify wood frame construction procedures. Conditions, given a classroom environment, a TM 3-34.47, a vertical structures workbook, and a highly motivated e-ball class. Standards, identify wood frame construction procedures in accordance with applicable references. So, wood frame construction, why do we build with wood? It's easy, it's cheap, what else? It's natural, it's pretty easy to get most places, right? It's fairly strong, yes. And also it's, most areas it's easily available. Disadvantages. It does not last very long, relatively speaking. It swells or shrinks, especially if it has not been kiln dried or treated. Now, what I mean by kiln dried or treated, wood, if it's freshly cut, is going to shrink. It's also going to warp a little bit. But we artificially speed up the process of drying so that we can use it for construction. So pretty much everything that you're finding at Lowe's or Home Depot or one of these other places, they're kiln dried lumber. Right? You do not want to be buying non-dry lumber, non-prepared lumber. Otherwise, again, once you put it in place, it's going to become a pretzel. So It is definitely not fire resistant. In fact, we use it to start fires with, right? Okay. Now, there's also different types of lumber, and besides different types of wood that are used, what is pressure-treated lumber? Who knows what pressure-treated lumber is? Okay.
They use like copper and pressure, so it pushes like an insecticide and some other stuff in it to help keep it from rotting and so on, and bugs eating it.
Okay, exactly. They put some, basically use several pieces of chemicals laden into the wood, and it prevents it from rotting and keeps insects out of it, and makes it last much longer. Especially if it's going beneath the surface of the ground, you definitely have to have pressure-treated wood. A little safety aspect to consider in here is not only should you always be having gloves on when you're handling any of your construction project, right? Especially when you're dealing with pressure-treated wood. It's a chemical, right? It is a carcinogen. You're handling that quite a bit. It's going right into your skin. Okay? So make sure that your soldiers are wearing their gloves and are wearing their proper PPE as they are always doing. So when we talk about our nails, we have the 8-penny nails. You're going to use different kinds for different situations. What size is this again? 2 by 4. So with this rule of thumb right here, if you're going to straight nail 1 inch thick lumber, would I use a 8-penny nail for this? No, I would not. This is too thick. However, I could use it to toenail this in. And what do I mean by toenailing? All right, if I have to nail it in like that, basically, if I'm nailing from this board here at an angle here, if I use a larger or thicker nail, it's going to split this board right up the middle. So I use a smaller nail to toenail it in. The anchors, in some cases, allow you to do that even if it's hanging off the side. If you notice that one, hold that one up right there in your left hand, right here. See, this right here will allow you to nail straight into the board and apply the weight directly off of from one piece to another. All right, there's another example over there with a hanger on top of it that grabs from the top of the board. So these allow you to break the old rules, so to speak. They're also time savers. They're very inexpensive, and you should be using them for your construction. And usually you can get them downrange, or at least through ordering back to stateside. We've spoken about the different elements, the different pieces that go into it. Now we're actually going to talk about building and attaching it to that foundation that you had there. So what you notice is a foundation wall, and on the right picture. On the other one, it's a combined slab and wall. And what they've done is they have an anchor bolt coming through. And what an anchor bolt is a bolt that's been set into the concrete before it's dried, and it's sticking up out of the concrete. There are other ways to do this now, more modern techniques, but that's basically what it is. And when it's time to actually start building your wood frame construction, you have your sill, which is placed directly on top of that, albeit with a moisture barrier in between. And they will drill a hole through that and just basically set those on all the anchor bolts and then bolt them down. They'll get lagged down, and now your superstructure is permanently attached to your foundation. Now, so next aspect we're going to talk about is the girder. The girder is the part that's the intermediary support in between the rest of your foundation. And not always on your foundation. It could be on your ceilings, so on and so forth. If you have your floor joists, and that's those ones that support your floor, the boards underneath that support your floor, they are not going to be reaching the entire span of your room. How big is this room right here, right? It's pretty big. I would probably say it's a good 20 feet to the back wall. Am I going to reach that back wall with a 2 by 10 by 8? What do you think? No? So I have to have some intermediary supports for that one ends and the next one picks up, right? Yes? So that's what your girders do. Hence, we're going to go back to this picture here. You notice your floor joists right there and right about there. And the girder is right there to support that weight on the other end of them. So, and this is probably like a little better diagram, exactly what you saw there up on the right. And you notice that they cross right on top of the girder, and whenever you can, you try to have that foundation support directly underneath it or some kind of column. Hence, going back to what we did earlier with our demonstration, right? Try to apply weight directly down as much as possible. Now, when they overlap like that, why don't they just butt up against each other? What do you think?
To continue the strength of the board, so kind of like this, or concrete, we need to splice it.
Very good. So it continues the strength of the boards, kind of like concrete when we had the splice overlap. Perfect example. Okay. There are other ways of also doing this. That's one with a joist hanger, as you see, which you guys are looking at right now in your examples in your hands. And also another one is basically creating a bite on it or a cut, right? And what's going to happen is you'll just put a shelf right there on the bottom, or we call a ledger. And it basically supports some of that weight. This is the bottom left-hand version. That's rather old school. You don't see them very often, but they're still out there. Wood has a crown on it. And what's that? Yeah. So what happens is a board, if you go ahead and you won't notice it on something like this, but you get a 2x4x8, and you look down the board, and you're going to see that there's a bow to it. Right? Right, Oxley? Yes. Okay, you're going to find a bow to this board, and it'll basically, it's a natural curve that all wood's going to have. And you're not going to get rid of it. You're not going to make it go away. And you're not going to get rid of your lumber if it just has a slight crown to it. But what you're going to do is you're going to mark it. And in a case like your floor joist here, you're going to make sure that your crown is up. Why do we want our crown up in our floor joists?
Once the load, once it starts bearing the load, it'll level out.
Once it starts bearing the load, it'll level out a little bit, and it'll push up. Now, if I put the crown upside down, what do you think will happen? Okay, tell me, Miller, what do you think? You'll have a sag. And then your plywood will be sitting on there, and what will happen to that? It'll sag with it, or the other case, it won't sag, and basically, every time you step down on it, it'll push down. You'll have this gap. You ever hear like floor creaking, and you got like a little bounce on it? You can almost like a little mini trampoline right there. That's because the crown of the wood is going down, and the plywood isn't. So now, every time it pushes down, it's actually pushing the nail head up. And some of you guys may have seen this on decks. You may have seen it in floors. It's going to happen a little bit on decks anyway, but it'll happen very quickly if you have floors where the crown's going upside down and the plywood isn't bowing with it. So not only that, it also weakens the floor. Not something we want, do we? So next thing you're going to talk about here is making that floor a little bit stronger in other ways, and that is the bridging. The bridging is basically not permitting the floor joists to do this. You know, they're going to twist over time. They want to turn sideways. They're going to look for the path of least resistance, just like a lot of things and a lot of people, right? All right. So if you have bridging in your between your floor joists, basically it's not going to allow them to twist or turn or fall sidewards, and it's going to use each other to provide support for the next one. So there are different kinds. Usually we use solid or block bridging. Often that solid or block bridging is your scrap from other parts of your project. Okay. The other thing that you might find is cross bridging. Cross bridging is a little bit more old school. If you find the wood versions, it takes a long time to cut, takes a long time to install, and it's very easy to split and break them. However, there are more modern techniques. You might find our metal cross bridging right here. They are a pain in the butt to deal with because they can break easily during installation. However, they do provide an added feature that solid bridging does not. And that is that you're able to pass wires, cables, pipes, hoses through that area and not have to drill through your bridging. It's already there. Sometimes you might use a combination of both and just put the cross bridging where you need it. But often you'll find a person using one or the other.